could I go on?
Yes.
Okay, we use drones today both in infrastructure, city infrastructure, and some rural areas. The first case is the case which was done this year, about maybe a month ago, in Kyiv region, and I called this case a bridge. The city is Irpin, which was liberated about 1 year ago. I think everybody heard about it in the news weeks and so on. So in Kyiv region, we have almost 5,000 private houses which were destroyed, and about 16,000 which were damaged. 161 apartment building was completely destroyed, and about 1,000 was partially damaged. As you see on the slide, according to the previous point, a large amount of specialists which will work remotely are needed, and they have to serve several objects at the same time. In other hand, we have a poor and partially missed technical documentation for these buildings we need to reconstruct. And one more problem is from city administration, which always change their plans and try to modify projects during the process. So we need some solution to build the bridge between city government, experts which are working in the fields, which are measured in the fields, which are examining these buildings and so on, and distant professionals such as engineers, architects, and other experts. The first one is a 144 apartment building, which is located in city Irpin. What was the input data? The input data was 350 oblique images. Oblique images taken from the drone are images which were taken from the angle. For example, 45 degrees or 30 degrees, it's an oblique image. And when I will go on, I will also talk about nadir images. Nadir images are taken just in parallel to the terrain. So the degree is 90 degrees. For this model, it was taking about 1 hour of the field work, which I was working with the drone in the field. 2 hours of studio work of downloading images from the SD card, preparing them to the software and so on. And 4 hours of computer processing, which was done without me. I just leave the computer and it worked. What was the output data of all this project? The first one was the cloud-based 3D model with a point cloud and 2D orthomosaic. The next was the topographic survey in scale 1 to 500. Orthophotoplane also, and vectorized orthoplane in DVG format, which was used in AutoCAD software by our engineers. Now I'd like to invite you to my web browser, and I will show you this model in web. What is the first advantage of the cloud-based model? You don't need any additional software installed on your computer to work with it. So you can just get the link, paste it to your browser, and then you can work with the model. The quality of this model is a little bit worse than on the computer, but it's quite enough to take some measurements, to take some annotations, and so on. Here you see now the orthophoto plane of the object. This object is a 144 apartment house. And now we are turning to the 3D model. This is the 3D model of this house. You can, oh, I'm sorry. You can rotate it. You can change the scale. And you can do all the basic measurements on it. For example, I can show you measurements and annotations which were already done by me. For example, I marked some of the drains on the map. All my measurements can be viewed by third persons. And any information you can share from this model with other people. Now I'm turning more annotations. For example, here you can see the square of the roof. As you can see, there are 85 square meters. Here you can see the other one measurement of the roof, and some of basic measurements such as distances are also present on the model. The case of this model was to provide some information, some imagination of the building for the engineers they work with. Because now we have a lot of projects, and some engineers never visited this object at all. So they can work here only by photo material or some drawings. As you can see here on the model, I also can take some photo reports. For example, the real case was from engineers. They asked where the rain drains are located. So I opened the model and located them, as you can see here. If you click on any place of the model, you can turn on the photo report. So as you can see, aerial photography, yes, is opened in the side menu. So you can click on any interesting object on the model and get some photo report of this place you clicked at. For example, you need to find something on the roof. Maybe, okay, let's watch here. So you take this instrument and lots of real aerial photographs are present with this point. Okay. As you can see, all of this on all of these instruments, you can measure distances. You can measure polygons. You can measure circles and volumes. You can calculate real volumes. For example, if you need to calculate some maybe building trash after dismounting of the building, you can do it. You can mark some places, some points, and you can also have a photo report of all points of the interest you need. Here is presented a 3D mesh model. It's not enough accurate, for example, if you want to present it in some computer game, but actually the mission of this model is to get the full imagination of the object, of the object of your interest in, and actually you can watch all the environment of the object. For example, as you can see here, it's there is some of the red lines of the city are presented. So this is not the main street, but it's somewhere near. This output is called textured mesh. Also, you can use, for example, point cloud. Point cloud is less pretty to see, but it can be exported to any CAD or BIM systems. So you can work also with point cloud. It's more accurate to measure with point cloud, so you can use both of views as you want, and you can also view the orthomosaic on the 2D view. It has also a good GSD. GSD, it's a ground sampling rate. It means that 1 pixel on your display equals, for example, the polygon of 2 by 2 centimeters on the ground. So 1 pixel of your display is 4 square centimeters on the ground. Okay, this model is finished, and I want to show you more. Here you can find the link to this model. After the presentation, I will share with you this PDF file, so you can copy and paste this link to your browser and try to work with the model online. Also, additional outputs are available on the Google Drive. If you want, you can also download them from here. The next one model is a much simplified but a little bit faster model of the 72 apartment building. Also, it was taken from the city Irpin, Kyiv region. It was taken, I think, less than a month ago. As you can see, the spring is already present on the photo. So it took 147 images taken from drone. 20 minutes of the field work. I just drive to this location on my car, and everything was finished on the object in 20 minutes. 1 hour it took of studio work, and maybe approximately about 2 hours of computer processing later. Outputs in this model are the same as on the previous. Now I can show you this model. As you can see here, this model is less pretty. One wall is absent, but it was made very rapidly, and actually the main thing this model was made is to take a detail of the roof. So I did it much faster than previous model. And as you can see, it depends on what you need to do. Everything is the same. As you can see, there are some kinds of annotations, some drains, the wall, the roof, and the photo report. The functionality of this model is completely alike to previous. All the photographs in the photo report have a resolution of 20 megapixels. So if you need to watch some details, you can zoom it in and watch everything you need. The next one model. Also, I leave the link to this model and to the additional outputs if you are interested. The next one model is the model of the residential area taken in Bucha, also Kiev region. This model was created to make a control measurement of the roof after the reconstruction. So the city authorities decided to launch an inspection of the amount of the work which was already completed. The next feature of this project was a very tight deadline. Actually, I did it maybe in 24 hours. What was the feature? What were the feature aspects of this model? It took maybe about 4 hours of field work, more than 1,000 of oblique images taken from the drone, 2 hours of studio work, and 8 hours of computer processing. This model is interesting, first of all, because here you can see the all residential area. Now I can show it to you. There are 16 small apartment buildings presented on the model. Now you can see the model on the map. You also can change the view of the map, and you can see here the difference between image taking from the satellite, Google, and orthophoto plane. As you can see here, the difference in detalization. If we turn on the, I'm sorry. If you turn on the 3D view, you can see the 3D model of the area. The main goal was to make a detailed model of the roof to take measurements. So here we have 16 houses, and the square of each part of the roof of each house.
Can I ask
These control. What?
Can I ask a question?
Yes, please.
Why do you need to measure the roof?
It was a control measurement. When the builders finished, the city authorities tried to check if the control measure will equal the documents.
Okay, so it's like a check after the construction.
Yes.
To check.
Yes, it's a check after the construction. Yeah, and everything is equal. So the builders were satisfied, and the city council also was satisfied.
And controls will be satisfied also.
Yes, I think the police and prokurors also. Okay, let's go to the next model. The next model is a rural, not rural, it's a forest. It was much harder to build up the model in the forest area. It was taken in the forest of Mashun, Kiev region, and the challenge was to build the model of 3.5 hectares of area to take measurements, and actually we made a presentation for possible future memorial complex. The presentation was successful, and President Zelensky and also General Zaluzhny visited this area, and the money were founded to construct the monument. This is the real battlefield area, so some explosive objects could appear on this terrain. It's a little bit bigger scale than on the previous models. Actually, previous models were about maybe 0.5 hectares. Here we can see 3.5 hectares. And this terrain is much more difficult than city infrastructure, because high vegetation, trees are presented on the model, and a lot of trenches and dead wood after the battlefield is presented also. It was taken 362 oblique images. It was something like about 2 hours of field work, 1 hour of studio work, and 6 hours of computer processing. What was the output here? It was also a cloud-based 3D model with a mesh and point cloud. And we did a small presentation to state authorities where we presented the complete measurements of the trenches, of some objects are presented on this terrain, and also iconographs of the fallen soldiers. As you can see, there are many different models in my cloud already, but today I will share with you only a few of them. So this is our terrain. As you can see here on satellite, it was a forest here. And now, as you can see, if we will turn off the annotations, it's completely difficult here to see what is going on here. So I had to use some tricks to build a good 3D mesh model. As you can see here, the upper part of vegetation is cut, so you can see what is going on terrain. For example, here is the future monument, some trenches which we were measured. As you can see here, also photo report of blindage is presented. Some portals are successful. As you can see here, a flag, a place of death of some soldier. You can see it here. So the goal was to have all the to make all the measurements because these trenches, they need to be restored and preserved for the future to show people how difficult was the battle of the Kiev Gate, as it's called now. This model also presented in my PDF file. So if you want, you can take it and watch. The next one. The next one case is a classical case which is a classical case of the drone usage, classical visual inspection and photo report from the call galleries and production hall building with 3D model of the roof. This area featured 150 nadir images and maybe 500 custom shots of objects of the interest for the technical report. It was taking close to the front line, so we had to get lots of different permissions. It is located, I think, about 30 kilometers from the front line. I also can share with you some of the views. As you can see here, I built up this model just to check the roof. So the walls are not presented on the model. It was built just to check the roof of the production hall. Also, points of interest are available, so you can check any place on the roof and get the photo report from the model. Okay, I think that's enough from me for today. Everybody's tired. Thank you for your attention, and if you have any questions, I will answer you.
Thanks a lot. That was super interesting, Ilya. I'm actually wondering if Ksenia has any comment.
Hello to everyone. Ilya, can I ask you how many people you have in your teams?
Actually, our drone team consists from me and from Dmitro only. All the models and all the flights are made now by ourselves because we just launched our project a few months ago.
Yeah, it's very interesting, and I have conversation with military, and they also very interested in these 3D models. And I show a small presentation. We had this presentation 2 months ago, I guess. Yeah, and they're very interested in this. If it's possible, I can share your presentation.
Yes, I will. I will make a PDF file of this presentation right now, and I think I can send it to Wagan or somebody else. If you are interested in this presentation, you can also contact me directly via the phone or maybe via the email. It's not a problem.
Yeah, thank you very much.
Thank you.
Good. Yeah, and thank you for your job. It's very useful. I guess in future it will be useful, and now it's very useful.
We are trying to popularize it among the engineers because it's very difficult to, you know, to present this abstract work, and we are trying.
And also, I was in meeting. I don't remember name this company, but they work in Amsterdam now, and they create something like this, but with digital camera. For example, this private company, they provide this new technology, and also they have money from Gementa. This private company, but this business project. It's not government project, but it's a private business project. And this, in one place, they have free digital camera, and they have in real time. And this camera work all time. Not, for example, one people have work with drone 2 hours and then create. No, this camera located in this place, and then automatically create a 3D map in this area. This is also very interesting. If you're interested in this project, I can find these contacts and maybe I can send
it will be good.
you.
And one more thing which I wanted to add to my presentation. First of all the inputs from the drone can be combined with the pictures taken from the ground. So you can combine when processing, for example, with some mirror camera or something, or some 3D laser scanner. Also, the outputs of this work can be vectorized, so you can export, for example, it to CAD systems and to BIM systems. It depends on the actually on inquire what you need to get on the output. We also can export different formats. Thank you.
Yeah, thank you.
Nice. I don't know if you know, Ilya, but Ksenia used to work for Ukrainian Cadastre and also now works for the Dutch Cadastre. So that's the connection.
All our models are made with GNSS, so it has also geodesical data inside. So you can measure coordinates, points, and so on.
Yeah, it's very good point. Yeah, it's very useful.
Thank you very much. So, any more questions?
Yes,
This
a little question.
Yes,
Sorry.
Vagan, please. Please.
Yes, thank you. A little questions we discussed when I first see this results. Does this technology can be used to create the digital twin of the city? And how you think, for example, from I don't know, from city like Mariupol, you know, the sizes and so on, how many time you need for this?
I think it depends on the quality of the model, how detailized it could be on the digital twin. For example, if you need a more detailized model, it can took much more time. For example, one house, I don't know, 115 apartment house building with the environment, it will take approximately about 10 hours of the computer processing. But for example, the model of the residential area, which was shown on the second case, it took maybe 8 times of processing. So if we can divide the whole city to different locations and begin to digitalize it, I think it is possible to make a first digital twin of the city. It can be not really accurate, not really detailed, but it will be a material to start with. I think it will take maybe 4 or 5 months, maybe half a year, something like this. It depends also on a team which will work on this. And the second feature is we can make a good orthophoto plane of the city. For example, when GSD is maybe 1 centimeter, so every drain, every tree, every trash bin will be presented on it, and you can use it as a background on the GIS system to draw different layers on it. It will be much more detailed than, for example, Google Earth or some satellite shots, which currently present in GIS systems.
Okay, thank you.
Thank you.
I have questions. Next week, you can present this information of Ukrainian language, Ukrainian city, because every 2 weeks, UNUN have Ukrainian meeting and present best practice Ukrainian city.
Yes, of course, it's not a problem. We will be very great to make one more presentation.
Thank you.
Thank you very much.
I would like also to ask stakeholders of these projects. Who ordered them?
So the first one is the construction company, which now makes a reconstruction of these buildings. Because on the first two models, it's not shown, but these houses were a little bit damaged. Some roof and maybe some glasses. But the city council decided to renovate it completely. So we took these models for the reconstruction building company.
Okay, Maria has a question.
Yes, I have questions. Thank you. Every day our military zone change, and higher of your orthophoto plan is very important. My answer: how on what higher you can work?
Now we have some limitations of the height of the drone. I think 100 or maybe 120 meters, it's the upper level, which is allowed now to work at. Actually, when you fly upper, you can face some problems with your drone because you can just miss it.
Thank you.
You can miss the control and can miss the drone. Actually, the allowed position on which we work now about 60 or 70 meters. I usually work at.
Okay, thank you.
Thank you. Also, we need a permission from the city authority and some military council to work with the drone.
Are there any more questions? Okay, Ilya, can you then stop sharing your screen so we can see everybody?
Yes. Thank you very much.
Thank you. Okay. Well, we actually had scheduled a Gerhard's presentation about regional waste management. It will have to wait until next week, I'm afraid, but that's okay. And then for next week, then we will have also this presentation, but then in Ukrainian for the Ukrainian edition of this book. And maybe it's sorry, children. Maybe it's interesting if you and Ksenia can have a contact before to see if the cadastre and your initiative can somehow combine forces.
Yeah, with pleasure.
Okay.
Thank you. It will be great.
Yeah, and last question: where are you located? Because you
Now we are
have,
located in Kyiv.
Okay.
Now we are located in Kyiv. Yes.
Okay. Perfect. Yeah.
Okay, and as I mentioned in the invitation and email update, next Wednesday, so this Wednesday, there's an event for the network of UN, which is happening in Rotterdam in the festival terrain of Maasur. If you can make it, that would be great, because then we can reflect on the year that has passed of UN and brainstorm the future. So also this group and what we're doing here, basically sharing knowledge. Some of the people are not on that mailing list, so if possible, Mikola, because I guess you have everybody's contact to forward the invitation for the event on Wednesday.
Nikolai, microphone.
Oh, sorry, I moved. Yeah, sorry. This meeting in Rotterdam only offline, but online too.
No, it's only offline. It's in a warehouse. It's in an old factory building, so there's no.
Okay, I, Wagner, and Mikita plan visit on this meeting.
Nice.
I
Okay.
think Maria
I
also.
also plan. Yeah, I with pleasure. Yeah, I really would like to be attending this meeting and see all of us. It will be very nice.
Okay, and for now, thank you very much for the presentation.
Thank you very
and
much.
Have a good evening, and until next time.
Thank you very much.
Good evening, guys. Stay safe.
Goodbye.
Thank you. Bye.
Bye-bye.
Yeah, bye bye. Thank you.
Have a good evening. Bye.